Not that quick. Right, so we get doing a quick revision here, and then let us start some transformation matrices. So you had given this question 11A for homework, very good. So I'm correct now. What's the way I can say to the huh? ENB. Some people did their homework and they waited. And they are waiting. All right, so let's start correcting the homework. I go with the problem. Let's start correcting the homework, right? All done? Right, just correctly homework there. So wow. Right, so if you look here, first thing first, right? First thing first, they told us that the matrix does not have an inverse. What does that mean? You know, what does that mean? If it doesn't have an inverse, the matrix is what?
Single.
Right, correct, is singular. Right, the matrix is singular, therefore the what? The determinant is 0. Right, so how do we find the determinant? 7 multiplied by -1 minus 2 multiplied by equal to 0. So you're going to get -7 minus 2p is 0. We're going to solve p, right? So I'll get -7 is positive 2p or -7 and 2. Yep. Okay, Nadia? Right, take your time with the signs, right? Let's take your time with the signs. Again, notice when I'm looking it out, I made sure it's brackets, right? Right, so wait it. Next one, let's do the simultaneous. Let's do the simultaneous. The camera come back again. Right, next part. What shall the X and Y online message answers now, please? Oh wait, hold on. Message answers to the one that let's tell them to message. Right, so when I'm messaging online, message Nicholas Paul, right? All right, next part. What do we have here? We have 4x minus 2y minus 0. 2x plus 3y is 4. Right, with the derivative to whiteboard. I just get back to whiteboard. I suppose to be with that's why that's trying to figure out where did it whiteboard symbol. I use the camera. All right, so I had to figure that out sometimes. Right, so what was the equation again? 4x minus 2y is 0 and 2x plus 3y is equal to 4. Right, so right, so step number 1 is to write it like this: ax is equal to b, and then a is what? 4 minus 2, 2, 3. Right, so I'm taking all the values here, right, Robbie? Watch it here, because this missed last week. I know what you could do. Right? Multiply by xy is equal to the answer, which is 0, 4. Okay? Next step is what? Next step is to take A and find inverse of A. So inverse of A is 1 over the determinant, which is 4 by 3 minus 2 by 2, which is minus 4. And then you switch around the 3 and the 4, and you put a minus by the 2 and the next. So we'll end up with 1 over 16 by 3, 2, minus 2, 4. Right? Next part, to find x, you multiply A inverse by B. So that's 1 over 16 by 3, 2, minus 2, 4. B is 0, 4. Right? How do we multiply matrices again? Row by column. So you multiply row in matrix 1 by column in matrix 2. Okay? So that's 3 by 0. That's 0. I'm multiplying here by here, right? 3 by 0 is 0. 2 by 4 is 8. Minus 2 by 0 is 0. 4 by 4 is 6. So we get 8 and 16. So you'll get 8 over 16, 16 over 16. So the answer is a half and 1. Nice. Let's go again. Copy down. Let's go again. Right, you have to write it in form, find the inverse, and then multiply, right? Coming up, let's go again. Huh? Taking it off, right? Huh? Alright, so let's take a look at this. Last one, 2017. June 2017, number 11. Read the instruction properly. Yeah? So you're going to practice multiplication and right, this is June 2017. Get all of the 1, 2, 3, 1, 2. Doing everything. Absolutely start transformation. Transformations of our question. Let's make a reflection. Fraction. By just multiply again. Row in the first matrix by column in the huh? Right? If AB is not equal to BA, right? Just hold up. If AB is not equal to B by E, then what does that mean again? What's the word? Wait. What's the word? Associated. Yeah. We're going to see commutative, right? So matrix multiplication is not commutative. Okay? So you're supposed to get part one already. You're done? Right, how do I write? Oh yeah, it was. What is number here? I remember what year it was? 17. Right, remember I told you you'll miss one Wednesday class on the 18th, I think. Right? But I'll remind you. All right, let's start. All right, so let's start here first with the matrix multiplication part. Huh? Let me finish up. I just need a little help to do A by B. Right, help me with the multiplication, please. Yeah, Faith. Can you multiply these two matrices? Yes, because they are what? What's the word? C. Conformable, right? These matrices are conformable, so we can multiply them. Right, that's multiply it. Put the multiply again. Right, row in matrix 1 by column in matrix 2, right? 3 by 4 is 12, and then 2 by 3 is 6. Very good. Go again. Wait, no, same row. Same row, next column. 3 by 0 is 0, and then 2 by minus 1, nice. So now you finish the first row, next row. What would it be? How many in the 7 here? Right, yeah. Next row, please. 5 by 4, and then 4 by 3. Then go again. 5 by, and then 4 by negative 1. So we ended up with 18 minus 2, 22 minus 1. Okay, that is A by B. Now let's switch it around and do B by A. Huh? 22. Which one? Oh, 3 by 4 is 12. Oh. Okay, yeah, 32 here. Sorry, 32. 18 minus 32. Because we're doing 5, 4 by 4, 3. It's 3, 2 by 4, 3. 3, 2 by 1 minus 0 minus negative.
So that's not supposed to be 0 and 4?
Yeah, correct. Negative 4. All right, something wrong with that screen there, right? So let's use here. Right, he was, what was he earlier? What was the matrix A? 3, 2, 5, 4. And he was what? 4, 0, minus 1, right? So A by B was 3, 2, 5, 4, 4, 0, 3 minus 1, right? So let's multiply back here, right? So A by B, 3 by 4 was 12, 2 by 3 is 6. 3 by 0 is 0, 2 by minus 1, minus 2. 3 by 3 is 9. All right, watch this here. We're multiplying this by this. So you're multiplying 3 by 4, and then 2 by 3. So 6. Next one is what? Next one is row by column again. So 5 by 4, that's 20. 4 by 3 is 12. Then row by column again. 5 by 0 is 0. 4 by minus 1, minus 4. So the answer here would have been 18 minus 2, 32 minus 4. Right? Then we have to find B by A. I change color here. B by A is 4, 0, 3 minus 1, 3, 2, 5, 4. Right? Can I get some help here? Here, Malachi. Help out here, huh? 4 by what? Which is 12, and then by 5. That's 0, right? What's the next one? Right, go by column here, so that's 8, and then 0 by 4 is 0. Go again. Next one. 3 by 3 is 9. Let's take that one right now. Then what? Minus 1 by 5. Again. 3 by 2, 4. So you end up with 12, 8, 4, 2. What does that mean? It means that AB is not equal to BA, right? And as I told you before, matrix multiplication is not commutative. Okay? So just remember that, right? Not commutative. That's part 1. Part 2 was what? Part 2 was to find the inverse of A. All right. Not play, but I don't know what's wrong with this conclusion. Oh yeah, find the inverse of A in case it didn't reach us yet. Find the inverse of A. Right, I tell you, how you find the inverse of A? 1 over 1. 1 over the what? And what's the determinant of A? 2. So the determinant is 12 minus 10. And what is do after that? How you do that? Right, so it's 4 and 3, and then minus by the 2 and the 5. Nice. So the inverse is 1 over 2 by 4 minus 2 minus 5. Okay. What was the last part now? Right? Right, and the last part multiply A by A inverse and see what you get. Multiply A by A inverse. What the answer is supposed to be? I gave it this already. 1 E by A inverse. Anybody online? When you multiply E by A inverse, what you got? The answer is the identity matrix. I. The answer is I. So don't forget to multiply by the half on the outside. So you're multiplying A inverse, that's this matrix here, by A. And it's supposed to get I, right? Try it backward. And then let's start transformation. Okay, again, here also. It includes a half 5. Right. Oh yeah, multiply that and you're supposed to get I. Last multiplication we do it. Last multiplication, so try that quick. All right, well done. Right, you know this. All right. Let us take a look at this. Graham, Kilo. Go ahead. Yeah. One, this one. Right, so let's multiply this out. So I'll leave in the half for last, right? Friday. Wednesday and Friday. Right, so row by column, 3 by 4 is 12 minus 10. Row by column again, minus 6 plus 6. Row by column again, 20 minus 20. Row by column again, minus 10 plus 12. So you'll be left with a half by I've seen a 0 here. This will be 2002 When you multiply it out, you're going to end up with a half by 2. That'll give you 1, 0, 0, 1. Right? Which is the identity matrix. So in case it's the first time you're seeing this, remember A by A inverse will always give you I. Or the other way around. A inverse by A will always give you I. Alright? Always end up with I. Once you multiply any matrix by its inverse, you'll always get I. If this is showing multiplication. If they have to 1 mark, just write that. Alright, so after this now we're gonna take a look at something called transformation. Hopefully you'll remember what transformation, right? So the first thing you're gonna do, right? I'm gonna first thing we'll do is just run over what is transformation.
Yeah,
Alright, this thing will be trouble. Let's give trouble last first or something. All right, let's kind of review transformations, right? Let me see. We could pick on. Jaden, give me one example of transformation. One example. Jaden, one type of transformation, Jaden. One. Just one, Jaden. Not 2, not 3, just 1. Okay, let me hear. Jaden, none? Keelan, since you're looking for it already. What's an example of a transformation? An example, and I can ask you to explain it. We have a shape and you move the shape. What else? A reflection, right? That's what? Reflection. What's the next one, Ravi? That's weird.
The dilation.
Anyway, reflection. What's the next one?
The dilation.
Translation, just a slide, and one more.
The dilation.
Those are the 4 transformations that we have to do. Right? Quickly, let's just look them over. Right? Before I give you the matrix for each one, right? Okay, fine. It's here. Alright, so what is here? Rotation. What do we need? What do we need to describe rotation? Number 1, center. Number 2, angle. Number 3, direction. Here's an example of rotating A to B. Anybody remember? Anybody can describe A to B? Describe A to B for me, please, Kelly. Describe the transformation from A to B. It rotates across the axis. I don't like that. So it went clockwise or anti-clockwise? Clockwise. About what is center? Looking like 0, 0. So it went clockwise. So it went this way, clockwise, 90 degrees about the center, 0, 0. Okay. Okay with that? So it went from. I don't feel someone okay with that. Huh? Where is the center, right? Right. So it went this. So it went. This one have more function. Let's save. Let's clear. Redo. You can see. Sure. Yeah, but I still can't. I still can't take off this and use the whiteboard. Right. Anyway, so you're going this way. That's clockwise. This is the center, and if you measure the angle between here and here, sorry, between here and here is 90 degrees. All right. So that is your first transformation. Right. Next one, reflection. Here's a reflection. Anybody can describe this reflection here? How is reflect E to B? It's not looking even, but it is even. It's a reflection in what line? How many? E to B is a reflection in what line? The x-axis. Nice. Right? It's a reflection about the x-axis. What about here? What is this here? This here is a slide or a translation from A to B. Right? How you work out the slide, right? How you work out the slide? Huh? So watch it here. So you take this point and you take this point and minus it. Okay? Take those 2 points and minus them. Anybody can do it mentally? Primary school, yeah. That's what I like to hear, the primary school thing. So it went down 1, 2, 3, 4, and it went to the right. Plenty. Right? So it went to the right, 1, 2, 3, 4, 5. 5 to the right. So it went 5 to the right, and it went 1, 2, 3, 4 down. So what do I do? What do I write? 4. If it went down, it's what? Negative 4. Negative 4. So the translation here is 5 minus 4. A translation also colon slide. Okay? So you just slide in it, right? By the way, this is an example of a what? Column vector or column matrix. Okay? It's also an example of column matrix, right? And last one. Right? And last one is the enlargement. Okay? Here's an enlargement. How you figure out the scale factor, Ricardo? How you figure out the scale factor, Ricardo? How you know the scale factor from A to B? Huh? Yeah, fit? Want to help it? What's up? Yeah, or just count the length here. 2 blocks. How many blocks here? 4. So it's 4 divided by 2. So that's a scale factor of 2. That's okay? Nice. Scale factor of 2. Oh, by the way, how you know the scale factor of positive or negative goal? How is it positive or negative? Kila? Anybody? FX? How you decide on that? No. Anybody want to remember? Follow it by example. Yeah. Now. Yeah. What's our online? Anybody remember? Anybody? Anybody? How you know if it's positive or if it's negative? Yeah. How do we do image appears upside? Kinda, yes, kinda, right? But here's what it is, right? Okay, who draw those lines there? Those lightly shaded red lines there. Oh, anyway, all right. So if you look here, right, you'll notice that where all the lines meet, that is your center of enlargement. And whenever the image is on the same side as the object, positive. If the image were here, then it would be negative. That's okay? Kind of the same thing as flipping it over, right? So if the image on the same side as the object is positive, opposite side is negative. All right, nice. So these are all the transformations that we have to learn. Now we have to learn all the matrices that'll give you this. All right? Now we have to learn all the matrices that'll give you this. We'll do that. Come off now. Get back to the other two. All right, nice. Right, let us take a look at all the matrices. Yes. Yeah. Right, I'll share this in the group as well, right? So you will have it. All right, so let's start here. Right, I know it's a little blurry, sorry then. Right, but the first matrix that we have to learn is the reflection in the x-axis. Right, I wanted to show you how it works. Right, so write down the first one, and I want to give an example. In fact, let's write down all four. Reflection in the x-axis, that's the matrix you have to learn. You will recognize that all these matrices are 2 by 2. Okay? And as I said, sadly, you have to learn all. Right? All these matrices are 2 by 2. Reflection in the x is the first one. Reflection in the y is the second. Right? So if they ask you to write the transformation matrix for this, what you have to do is you have to learn that. I'll show you how to figure it out. Right? Anybody remembers what has happened when it undergoes a reflection in the x-axis? What is changed? If you reflect a point in the x-axis, what is changed? Right? And reflection in the y, and just one more there. The last one is reflection in the line y is equal to minus x. Reflection in the line y is equal to minus x.
So -1, 0, and the next one is what? Last one?
Last one is 0, -1, -1, 0. That's reflection in the line y equal to x. 0, -1, -1, 0. Right, how do we use this now? Let's take a look at reflection in the x-axis first, right? Let's take a look at reflection in the x-axis. Right, how's the matrix again? Right, the matrix, let's call the matrix T, right? The matrix was 1, 0, 0, minus 1. Anybody remember what is up on when you reflect in the x-axis, what is up on? The y value changes sign, right? So make a note of that. The y value changes sign. So if let's say in this first example, let's say I gave you a point, the point is 2, 1, right? And I'm going to undergo a reflection in the x-axis. How are we going to find that new matrix A prime? How are we going to get that matrix A prime? Right. That's what we'll do, right? To get that matrix A prime, what you do is you take the transformation matrix, right? So you take the transformation matrix A, let's call it T, sorry. Transformation matrix T, and you multiply it by A, right? So you're taking that matrix T, right, Elena? The matrix T is 1, 0, 0, minus 1, and you're multiplying it by A, right? In this case, A is 2, 1. I have a quick question. Can I write it like that? Can I write 2, 1 like that? Or I have to write it? Column, very good. Right? For it to be conformable, right? So you multiply it by 2, 1. Right? And multiply it, and you will see you'll end up with 1 by 2 is 2, 0 by 1 is 0. Right? 0 by 2 is 0, minus 1 by 1 is minus 1. So you're going to end up with, I have to write like this because something wrong with the bottom part here, right? 2 minus 1. So the matrix A prime will be 2 minus 1. Right? So this is your reflection. Is that correct? Is that correct? The x value stay the same, which is 2, and the y value change sign. Right, Ravi? Is that correct there? Sure? Yeah. What is happening when you reflect in the x-axis again? What is happening? The y, look at right there, Ravi, the y value change the sign. Yes. Right? Right? The y value change sign, right? So if the x value is 2 and the y value is 1, then it would recognize here that it changed sign, right? Right? Copy it down. While you're writing, suppose I gave it A and A prime. How are you going to get T? Suppose I gave it A and A prime. How do you find T? Any ideas? Jacob? Suppose I give A and A prime number 1. The first thing that you can do is identify the transformation and memorize the transformation matrices. Next option is to technically divide. So what you say? If you have A prime given it T by A, then T is what? T is A prime divided by, right? Which is like finding the inputs. I'll show you an example later on. Sapidam, let's go again. Right? What is happening in our reflection in the y-axis? The x value will change sign, right? Try this here. Try this here. The point is 4 minus 5. Right? Find p prime. The reflection in the y-axis. Right? Find p prime quickly. It's a reflection in the y-axis. So what's supposed to happen again? The x value is supposed to change sign, right? So go back to your matrices and see which one will give it up. Right? So p prime is, what's your multiplying of it? What do you basically use in there? Look for the word reflection and the y-axis, and let's follow the matrix. Minus 1, 0, and then what's your multiplied by? Multiplied by 4 minus 5. That's fast. Right, so when you multiply it, minus 1 by 4, that's minus 4, and 0 by that is 0, 0 by 4 is 0, 1 by minus 5 is minus 5. So you end up with the matrix minus 4 minus 5, which gives you the coordinates minus 4 minus 5. Right? -4, -5. So that's the way you use these matrices, right? Of course, you have most of them, right? Okay? Right, but how you can memorize them? So you can kind of help. What you can do to help memorize them? Okay. Anybody else? What you will recognize that the main matrix is what? 1, 0, 0, 1, right? And if you want to reflect in the y-axis, the x value negative. And if you want to reflect in the x-axis, the y value negative. Okay? So that's one of the ways to help you. I have a quick question. I know you all have the answer already. But suppose you wanted to memorize the reflection in the line y equals x. What happens to these points? If you reflect 2, 3, what do you get? 3, 2, right? So the x and y value just switch places. So my question is, how will the matrix change? What's your answer? What's the list I gave you? What has happened? These zeros become ones and the ones become zeros. That's okay? So it's important to memorize the identity matrix, right? Okay? For next week, I want you all to again look over rotation, and we're going to do all the rotation matrices and then some papers on that. All right? So next week, we'll take a look at some. We'll take a look at the transformation.